points, M and N are the midpoints of YV and XW respectively. So it means that M is the midpoint of YV and N is the midpoint of XW. So that way you see the diagram. Now they're telling us find the length of line SN of SN. So the line they are looking for is from S to N. From S to N, they are looking for that length. So what we are going to do is this. We are going to draw a line from S to N and then create a right-angled triangle. Because if N is the midpoint of XW, then also down here at ST, the point that we shall put here between S and T will also be the midpoint of S and T. If we put a point here in the middle and we connect this point to this point N, the line that we shall draw will land on line ST. But at this point here, this point is the midpoint of ST. So what we are going to do, we shall first draw that square. So let me first draw that square very fast. For line. Always. So that's my square. So there is point N here at the middle here. That point is N. Okay, now what we are going to do is we shall also put a point here in the middle here between S and T. So between S and T, there's a point here. We don't know what that point is, but if N is the midpoint of XW, then it means that also this point here is the midpoint of S and T if we are to draw a straight line from here up to here. But what they want us to get is, they want us to get the line S what? SN. That's the line they want us to get. So I'm going to draw this line using dotted lines. Okay, yeah. So at this point, this is 90 degrees because this is a line that is perpendicular. So this point here is 90. It's 90 degrees. That's 90 degrees. That's 90 degrees. Now, remember that this distance from here, from R to S, is 12 centimeters. 12 centimeters. And also from S to T is 12 centimeters. So this point which is here cuts the line ST into two. So that means that this is 6 centimeters. Also this one is 6 centimeters. 6 centimeters. Okay. So now what we need to know is, what is this distance from here up to here? Maybe I can call this point, let me call it point E. That small point there, let me call it point E. So we know that Distance YR, this is Y, R is 12 centimeters. So if this is 12, this is 12. So this is 12, this must be 12, XS is 12, and also YT is also 12 centimeters. So what does this one mean? It means that also this distance, NE, are you saying NE is also 12 centimeters?
Yes.
12 centimeters.
12 centimeters.
So that means that now I can find the length SN using Pythagoras theorem. So what I'm going to do is I'm going to draw out this right angled triangle. Okay. So this is S and this is N. So this is point E. So this is 12 centimeters. Okay, that's 12 centimeters. And this is 6 centimeters. So using Pythagoras theorem, I will say Sn squared equals to Ne squared plus Se squared. So Sn squared equals to 12 squared plus 6 squared. So you work out and you give me the answer from there.
Thirty-six plus 144.
What do you get?
Sn squared equals
180.
80. Root 180.
Okay, 180.
By square root.
So Sn equals to
13.4.
13.4.
13.4.
13.4 centimeters. 13.42. Here there is 2, eh?
Yes. Yes.
Okay, 40 centimeters. Okay, now, as you look through part B, they are saying find the angle between the planes M, N. Patricia, did you get this answer first of all?
Yes, but I use XN as.
Use the XN as. Okay, that is also okay because at X is 90 degrees. That is also okay. So where you pass, you get the same answer. Okay, let us look at part B. The angle, find the angle between planes MNSR. MNSR and UTSR. So now we are going to use the same diagram here. And we are going to draw the plane. First of all, we are going to draw the plane MNSR. So at this point here, we have M. Here we have point M. At this point, we have M. So I'll call this one point M. That's the midpoint of Y and V. So this is V. And this is U. Okay. So they are saying that find the angle between planes MNSR. So what we are going to do is we must first draw the plane MNSR. That's the first plane. So I'm drawing the plane MNSR. So MN, M to N. Okay. And then SR. So I join M to R. Okay. So you can see that is the plane that they want. They are talking about MNSR, that slanting plane inside. And then the other plane they are talking about is this plane, RS. They're saying UT, S, and R. So it is this plane at the bottom. This plane at the bottom. Now, what's the angle in between? So what we can do is we can draw, first of all, a line that bisects the plane MNSR. But before we do that, we should know we have the first plane, which is MNSR, and the other plane is UTSR. So these two planes have a common line. And we can say that the common line they have is S what? Is SR. So when you look at S and R, is being shared by the first plane and also the second plane. This first plane and also the second plane. So it means that now our angle is at the line, is along the line SR. So for us to do that, for us to determine that angle, what we are going to do is we are going to first draw a dotted line that bisects these two planes. But first, a dotted line that bisects the first plane, MNSR. And that line must touch the line SR, because SR is the line that is common. So it means that we are going to draw a line from this point to that point. So that line is the line that is bisecting the plane MNSR. So we draw another line that bisects UTSR, but that line should touch this same point here where the first line is. So it should bisect, the line we are going to do should bisect UTSR into two, but it should touch this point. And to draw that line, we put this one in the middle. So we are bisecting this into two. So we put this in the middle. And we have that. Okay. So the angle they want is this angle here. That's the angle they want. Members, are we together?
Yes.
Yes.
Yes, teacher.
So it means that if we are to draw a right-angled triangle here, you may not see it that's right-angled triangle, but if we are to draw it, this right-angled triangle is inside here. Because this line from here up to here is 12 centimeters. Actually, I've drawn it poorly. It should have been something like that. Just should have been something like that. So this is the angle they are talking about. So from S to T is the same as from this point up to this point, 12 centimeters. So at point E here, do you see point E of ST is at the middle, isn't it? So even at this point here, we have the middle point. And if we are to draw this line that comes from this line MN, this line we are drawing should touch this line at its middle point. So at the middle point here. So this triangle which was here was right-angled triangle. So it means that also this line we have drawn here touches this line along 90 degrees. So here we have 90 degrees. So it means that we cannot draw this line up to here. Are we together? Because when we draw it like this, that will not be a right-angled triangle. So we must draw a line that comes from MN to the middle here of this line. So at this point, it will be 90 degrees. Now, this point here touches this line at its middle point. So it means that if also E here is at the middle point, and also this point is at the middle point, if this is 6 centimeters here, then it means that also this one is 6 centimeters. Are we together, members?
Yes.
Yes. The other thing that I want you to take note of, that this angle that we want to find, that angle theta that we want to find, is the same angle which is here. I don't know whether you have seen that. Are you seeing that? The angle theta that we want to find is this same angle which is here. Is the same angle which is there. So we can use this triangle which is inside, or we can use this triangle which we already drew some time back, because this is the same angle that is between the plane MNSR and also the plane UTSR. It is the same angle. So if this is theta, it means that also this angle there is what? Is theta. So how do we find that angle theta? Because we know that if this is 6 centimeters, also this one 6 centimeters. If this is 12, we know that also this one will be 12 centimeters. Are we together, members?
Yes.
Are we together? Alexandria, are you there?
Yes, teacher.
Hey, good morning. How are you?
I'm okay.
Okay. So what we are going to do is we are going to use this triangle that we drew. It is the same as this one, isn't it? So we are going to use this triangle here and we find the angle theta. That angle theta will be the angle between the plane UTSR and the plane MNSR. But before I proceed, is there any doubt? Is there anyone with a question about that?
No.
No.
All right. So let us proceed, and so I'm going to use this same triangle here that I drew some time back. Okay, so this will be, I can call this one S, E, and N. So this is 12 centimeters, and this is 6 centimeters, and this is the angle theta. So we are going to use tan what? We are going to use tan theta, and we shall say tan theta equals to the opposite over the adjacent. So tan theta equals to 12 divided by 6, and theta equals to the tan inverse of, this is 2, isn't it? Of 2. So theta equals to, the answer in degrees. So what is the answer there? Cynthia, give us the answer.
63.43.
63.43, so 0.4 degrees, 63.4 degrees. That is the angle that is between the plane UTSR and the plane MNSR. That is the angle that is in between. That's the angle theta. Okay. Now we go to the next part. They are saying that find the angle between the planes. I don't know whether you are seeing that. If you need to copy out that. They are saying that find the angle between the planes VWSR, VW, it's called WW, W, S, and R. And also, another plane, M, N, S, R. So this one, what I'm going to do is that because I've already drawn different things inside this diagram, so what I'm going to do is I'm going to use a fresh diagram, and I draw those two planes, and we find the angle that is in between those two planes. So you are with me. Let us go ahead and we draw this cuboid, and we draw those planes which are inside. So let us do it together. I do, and you also do from that end. That's what I'm saying. So we are drawing the cube.
I didn't hear that at all. That's just uttered BS.
Just the way you are. Okay, one more.
Alexandria, are you the one singing?
No,
You are giving us a cappella, eh?
Jay, it's not me.
Okay, so we have that. Okay, now we are going to first do the plane VWSR. So can everyone do the plane VW, S, and R? That plane is a matter of joining these 2 points there and there. That's the plane VWSR. And the other plane we are talking about is MNSR. So I'll first draw my MN. I'll first put MN here. It's in the middle. So this is N and this is M. So this is M and this is N. So I have to join these 2 points. So let's make this one dotted, maybe. I don't know. Just draw it, not dotted, but something like that. Like that. And that. Wow. Let me zoom in there very well and you see. So the angle they want is this angle here, in between this angle here. That's the angle they want. Between VWSR and also MNSR. Okay. So this was T. This is 12 centimeters, and this is also 12 centimeters, and this is also 12 centimeters. Okay. So, but remember, we say that we found out this angle here. I don't know whether you remember. There's the angle that we found out between this and this. But let us first hold on a minute. We have only 1 minute which is left. So in that minute, we should figure out how do we get that angle theta. So what we can do, you can go ahead and draw those dotted lines that bisect, because the common line is SR. So you can go ahead and draw those dotted lines that bisect the two planes, the two planes together. Draw that